So today's a blustery day, but yesterday afternoon we had severe windstorms here. Unfortunately, I lost 3 panels off the back of my boat. And I'll talk about that in a minute. Right now I've got the others protected with ropes going across. They survived fine in the windstorm, but my three older panels that were on the back didn't. The glass is all cracked on it. Even though they're flexible panels, they have kind of like a glass-like material on it. I'm still going to test them. Maybe I could salvage them. More than likely I'll have to be buying new panels. The reason for them coming off, now I had them attached with neodymium magnets, and the 3 panels were actually bolted together, same with the ones at the front. I have them all attached together, so it's like one massive panel. And then I'd have them attached at key points with neodymium magnets. I estimate the back panels were being held on with a static force of 200 pounds of force, which is a lot of force. However, that is a straight static pull force. What I think we experienced yesterday was the wind was causing the canopy to buckle, to flap, and all of a sudden you have a shear force. And the way you get the magnets off, if I want to detach them, is I move them sideways, and which is similar to a shear force, and they come off fairly easily, and I think that's what happened. So new strategy is required. I'm now going to permanently mount them or put bolts through the canopy. That'll be my next strategy, because I don't want a repeat of what happened yesterday. I figured that cost me about $1,000. So it's a beautiful afternoon for testing the boat. I've been doing some adjustments on the motor to get it performing as best as possible. I've moved the motor up 1.5 inches from where I had it. This is better. The water pump works at this level. I could probably go up another, maybe even another inch, possible. I also angled the motor back, tilted it back a little bit more. I want to try and get the bow down a little bit more. I've been finding that if I walk to the bow, I could increase the speed a little bit for the same amount of power. So it's telling me that it's not trimmed just perfectly yet. Right now, I'm just doing 7.9 kilometers an hour, and it's drawing 29.9, 30 amps, so about 1,500 watts. The performance I'm finding so far at this end, at the low end of the bottom 1/4, 1/3 of the Elco performance, is not as efficient as my Torpedo Cruise 2.0. Don't know why. I'm still trying to figure that out, getting things sorted out, and I believe I need to go to a lower pitch prop on this motor. So that's one of the things I'm looking at. Right now, for instance, it's 7.8, 7.9 kilometers an hour. If I just turn that around, so 8.2 kilometers per hour, 8.7. So definitely when my weight shifts to the bow, I could pick up the performance. And so I was trying to angle the motor a little bit more so that it would be pushing the stern up a little bit and push the bow down a little bit. So I haven't quite got that quite good enough, quite right yet. I need to angle that a little bit more, I believe. Or put some ballast in the front. That's another thing I need to test out. So a few more experiments. So it's a beautiful day today, and I decided to take the boat out for a little test run. I've got the solar panels turned off, so I'm just measuring battery capacity during this test. Right now I'm traveling at 8.4 kilometers an hour into a 10-kilometer wind, and I'm drawing 1550 to 1600 watts in that range. My ammeter for my motor is just 29 amps. I'll increase that a tiny bit. I want to keep to about a 1600 watt budget for this test. My motor, right now the telltale tube is working fine, water is pumping fine. I'm still getting a little bit of too much water splashing up against the motor. That's because I extended the motor back, and I need to extend the fairing back as well, so that'll improve things a little bit. I also want to try going to a smaller pitch, lower pitch prop, and I think that'll help the performance. Right now at 8.6 kilometers per hour, 8.7, I need to get that up to over 9, so a little more improvement, and hopefully a lower pitch prop will do that. Anyways, today's test is for battery capacity. So to Deseronto and back is about a 24-kilometer round trip, and I'm estimating at this speed, well, about 3 hours, maybe a tad bit less than 3 hours. So with no charging going on to the batteries, I'm running on battery capacity alone, and that should take me down to, well, the battery bank is a 200 amp hour battery bank, so if I'm drawing 30 amps consistently, a little bit better than 50% state of charge, I would say. 55% state of charge. I'll have to do the calculations after, but roughly. So now, I have to apologize for my nautical terms. I like to use kilometers and kilometers per hour. Being a Canadian, we've been exposed to the metric system since the early 1970s. So I grew up with the imperial system, and then at 18 I was exposed to the metric system. So I'm kind of like most Canadians in a hybrid mode where we'll use a bit of both. I like to use kilometers for distance, for speed, land or water, kilometers per hour. For air temperature, I like to use Celsius. But then for water temperature, I like to use Fahrenheit. For weight, I like to use imperial, so I like to use pounds, even though I'm okay on kilograms, stuff like that, but I typically would refer to weight in pounds. For measuring, for any woodworking, I use inches and feet. So anyways, a mixed bag. So I had mentioned before in a previous video that I use neodymium magnets to hold the solar panels on. I am in the process of changing that because of the windstorm we had 2 weeks ago and ripped 3 of the panels off the roof. The reason for that was not because the magnets weren't strong enough. They provide a lot of force, but their force is pulling against each other. As soon as you add a shear force to it, you could easily dislodge them, and that's what I'm assuming happened. The wind was causing a shear force, and it released the magnets, and the 3 panels were flipped off and damaged. I have those repaired now. I'll be putting them on in the next few days. I've got a new frame made. I'm going to be securing the panels a lot better. I'm going to use bolts going right into the aluminum frame at key points. And I'll still use the neodymium magnets in the center areas, because I don't want to put a bunch of holes in the canvas. But the frame is complete. I now have to work on installing that. So that's another minor change I have to make. Lots of swans in the river. They can be aggressive, especially with young. So we are now at Deseronto, and this is the 12-kilometer mark from my dock. I'm going to be turning around now, and let's see what the status is. Okay. Status is 78% state of charge, so that's pretty good. So coming back, I've got the wind a bit at my side to the behind me a little bit. I am now going 9.3 kilometers an hour, much better performance, drawing the same amount of power. So this is pretty good. I've got to do something about a weed guard of some sort on the prop. Probably something similar I did with my Torpedo motor. I made a little cowling, because the weeds just wrap right up, right at the junction of where the prop joins the main housing, right in that area. So I need to do something about that, because that affects the performance. You know, when every watt counts when you're solar electric, then you need to fine-tune everything. So this area of the river has a real problem with weeds. You can see that it gets tangled, and the performance current draw is now up to like 33 amps. It was at 31, so the weeds are affecting performance. That's one of the things I have to work on. Well, we're coming up to the 5-kilometer mark. It's 5 kilometers from here to my dock. Going pretty good. I snapped one guy wire. It pulled apart anyways. Powerboat went by me, threw up some pretty good wake, and the canopy swaying sideways just yanked that wire right out of its connection point. So I need to beef that up. Let's see, what are we doing for... Okay, we're at 67% state of charge. Pretty good. So we are really going according to plan. So back home in Napanee, and after 3 hours traveling 24 kilometers, we are at 56% state of charges, which is pretty much what I figured I would be at. Now this is from the battery management system, and that's 56%. From my midnight solar controller, it's 57%. I would tend to think that the battery management system is a little bit more correct, just because it's taking into account, I'm assuming it's taking into account the power that it's drawing as well. Alright, I'm back out. This is the next day. Battery on my camera died, so I couldn't finish videoing what I wanted to video. Anyways, I've now moved the motor back to its original position, and you can see I don't have a problem with the water pump, even though it is sitting higher up. I want to try this just to see if you know, trimming it up as high as I have it will help at all. But the other problem is weeds. I'm getting weeds tangled around the base of the prop, and I just tried to untangle them. I can't get them all out, so I definitely have to build some sort of a weed guard of some sort, because every little bit of inefficiency in the prop will draw more power, and using solar electric as my sole means of power, I have to be extremely efficient and conservative on what I do. Now it's fine, I've got a 10 kilowatt battery, but if I want to go for the day, that's perfectly fine. I've got lots of power. But my plan is to go for the month of August on a major trip. And every day I have to budget how much power I'm going to be using. So that's what I'm trying to establish now, is what that criteria is, and how to make it more efficient. And like I said before, I'm going to be going to a finer pitch prop, see if that helps. But today's test is just to see how the motor performs in its original position. A little bit windy today, and just a little bit more testing. So with the motor moved back to its original position, the fairing is now doing its job and blocking the water from coming up on the shaft of the motor. Got the watch where I'm going here. It would be nice to drop the motor about another inch. But I think it's pretty much where it should be. And right now the wind is behind me, and I'm moving along at 9.4 kilometers an hour. But that's got the wind behind me. It's probably about a 15 kilometer wind today. I'm drawing 26 amps. So pretty efficient. If I was running at this speed all the time and at this efficiency, I wouldn't have any problems. The problem is when I'm going into the wind, there's a lot of resistance. So also right now It's 11 a.m. Eastern Standard Time in the morning, near the end of June. So, and it's pretty sunny today. I am drawing 400, or I'm producing 485 watts of power, and that's just on the one bank, which is a 900 watt bank. So I'm about, I don't know, 55% capacity, but the angle of the panels is not right perpendicular to the sun, so that's why. Now I could tilt the canopy, but I'm missing one guy wire at the front. I have to replace that today. That got damaged the other day. So I use on my calculations for trips a 50 to 60% rule. If I'm going to be going for 8 hours in the day, I like to use 50%. That accounts for different variabilities, some cloudiness moving in. Starting in the morning, it's not as sunny. Basically at the end of the day, you only have a certain budget you could use. Now, say I went over budget, well then I'm drawing down on the batteries, which is fine. That's what they're for. They give me the extra capacity. The next day, maybe I might break even. The third day after that, I might have to take a rest day or a very slow moving day to recoup the batteries. You only have so much power you're generating, and that's your budget. So it doesn't matter how fast this boat can go. I've had this boat with this motor, the 20 horsepower electric. I had it going about 17 kilometers an hour, which is a decent speed, but that's drawing 8 kilowatts of power at that time. So that would drain the battery bank pretty quickly. So you need to go at a very conservative speed to conserve your power, unless you're just going out for a day trip, and then you could come back and then plug it in, and away you go. Anyways, I need to fine-tune things a little bit more. So the next step will be to take the boat out of the water, replace the solar panels, fasten those down a little bit more securely, get a lower pitch prop to try that arrangement, and then I may or may not decide to switch back to my little Torpedo motor, which will push me along perfectly fine at this speed. This is my cruising speed for going up the canals, but it could only get me up to about 12 kilometers an hour if I crank it. So not really very fast, but for cruising at 9 kilometers an hour, it's very efficient. So that may be the direction I'm heading. It all depends on the testing with low pitch prop. So right in here, where the prop joins the housing, weeds will catch in there and wrap themselves tightly around that. If you're trying to be as efficient as possible with your solar electric power, and that makes a difference. So I want to protect against getting weeds wrapped around there, and I have made before a weed guard on my Torpedo motor. I'll show you that in a bit, but I'm just going to take
flexible piece of plastic off the back of a butter lid, and I'm going to goop it in place, glue it in place, right like that. And this will just cover that little slot, and it should allow the prop to turn freely, but also let the weeds get by this point. Anyways, it'll still get caught on the prop, but you could easily get rid of those by reversing the motor. And whereas when it's wrapped tightly around here, even reversing the motor, it's really difficult to get rid of them. So I'm going to glue those on and test them out, and we'll see what happens. So I have my little guard all gooped in place, glued and taped, and leave it for 24 hours, and then it should be ready to test. Of course, I won't be testing it till next week when I get the boat back in the water. Here's the little fiberglass guard that I made on my old Torpedo motor. So a little bit different design. I used fiberglass. I made a piece of plastic housing that would fit over the prop or over the housing here, and then I put a piece of fiberglass over that, and then took the fiberglass off after it was hardened, and it would just slip on like a little collar because it's a bit tapered here, a little bit harder to do. On my Elco motor, and then I used just a little bit of silicone to glue it on. On my Elco motor, I just used some plastic lids, margarine lids type thing, and I'll see how that works. If they come off, then I will just make them out of fiberglass instead. But it should be good for a test. Well, I've got a new prop installed. I bought it off Amazon. It's 8-inch pitch. The standard one was a 10-inch pitch, so hopefully this will improve the performance. Here's my little weed guard that I stuck on. It's just plastic, and I put a little bit of white silicone around it just to keep dirt from getting caught. Did a little bit of a sloppy job. So it'll be fine for testing. Then I'll remove that, clean it up, and make one out of fiberglass. I might continue the fiberglass right around through here. That's why I'm going to use this one for testing, see if it's required or not. I now have the motor mounted back on the main transom, and it's a tad bit high. It probably could go down, you know, ½ inch, an inch, but I think it'll be perfectly fine. I'm going to be putting the boat back in the water later today, and do a major test trip tomorrow to Sandy Cove. So I have my panels all reinstalled on my new frame, and it's very solid. I've got it bolted in key locations all around the panels, bolted right down to the frame, so it's going through the canopy, which I didn't want to do at first, but that's what I had to do. The areas where I couldn't bolt it down, I still use the neodymium magnets, and they will hold very well in a static up-down position. It's the shear force that is the problem. Here's one of my panels that I had to repair, and you can see it's covered with epoxy resin where it was all cracked, and same with the other two panels. They weren't too bad. One of the cables was yanked out. I had to solder that in place, but everything's working fine.